My dear students, today I am going to discuss physics for class 9, Newton's second law of motion, derivation and application. Now we have to derive the mathematical expression of Newton's second law, which is F equal to ma. That means force is equal to the product of mass and acceleration of a body. So this is the formula we are going to derive. For that purpose, this diagram is necessary, you see. Now look at this diagram. Now this is a body whose mass is m. Now it is moving with uniform velocity u. So a body of mass m is moving with uniform velocity u. Now when the body is at point A, it is coming from somewhere. It is coming from somewhere with uniform velocity u. Now when the body is at the point A, in this position A, then a force is applied on it constantly. Now note that word constantly. It is not like that you apply the force and stop, like kicking a ball. When you kick a ball, you just apply a force and stop. But this is not that case. You have to apply a force constantly, like the accelerator of a car applies a force constantly on the car so that it can have acceleration, or the brake of a car applies a constant force on the car so that it slows down and stops. So that constantly word is important. So this body was moving from somewhere with uniform velocity u. Now when it is at position A force is applied on it constantly. Constantly the force is applied for what time? Time t. After time t, the body comes to this position B. Now since a force is applied on the body constantly, its velocity of course will increase. Now from u, the velocity has increased to v. Now at this point B, the force is withdrawn. From A to B, the force is acting on the body constantly. The body is moving and has reached the point B. Now when the body is at B, the force is withdrawn. So after B, the body goes on moving, but now it is moving with a uniform velocity v. So before A, it was moving with uniform velocity u, and after B, it is moving with again uniform velocity v. Now between A and B, during this distance s, this is the distance s. So during this distance s, the body has acquired acceleration because a constant force is acting on it. Now acceleration means what? Its velocity is constantly increasing. Every second velocity is increasing at a definite rate. That is the meaning of acceleration. All right. When you apply accelerator of a car, its velocity increases constantly at a definite rate. Similarly, when you apply brakes on a moving car, it acquires negative acceleration and finally slows down, isn't it? So this body has moved from A to B through a distance s. From A to B, it takes time t, and during this distance s, the body has acquired acceleration a due to a constant force F acting on it. So before position A, the body was having uniform velocity u, and after position B, the body is again having uniform velocity v. All right. So this is the explanation of that diagram. Okay. Now, so let us see the initial momentum. Initial momentum of the body. Now momentum of a moving body is mass into velocity. A moving body has momentum, that property, which is equal to mass into velocity. Now initial momentum of this body, so mass m, initial velocity u, so m into u, mu. Then final momentum of the body. Final momentum of the body. So final momentum equal to mass into final velocity mv. All right, mv. Now change in momentum. Change in momentum of the body. So this is final momentum, this is initial momentum. So final minus initial. So that will be the change in momentum. So mv minus mu. So this is the change in momentum of the body. Now this change in momentum has taken place in what time? T. Now rate of change of momentum. Rate of change in momentum. This is a change in momentum taking place in time t. Therefore, rate of change in momentum will be what? This divided by t, because rate is always divided by t, isn't it? So this t divided by t, mv minus mu. So this is what? The rate. This is the rate of change in momentum of the body. All right. Now the second law of Newton, Newton's second law of motion says what? The rate of change of momentum of a moving body is directly proportional to the applied force. So according to Newton's second law of motion, this rate of change of momentum is directly proportional to the applied force F. That means now according to Newton's second law of motion, this mv minus mu by t, this rate of change of momentum is directly proportional. Is directly proportional to what? The force applied on the body. So after this, what you will write? According to Newton's second law of motion, rate of change of momentum is directly proportional to the applied force. Therefore, this rate of change of momentum is directly proportional to the applied force. All right. So therefore, F directly proportional to mv minus mu by t. So this is directly proportional to F. So we can write conversely F is directly proportional to F. So here we are using the law of proportionality. Law of proportionality says what? If X is proportional to Y, then Y is proportional to X. So there is a chapter of proportionality of variation in higher class. You will see there are laws of variation, laws of proportionality. This is the first law. If X is proportional to Y, then Y is proportional to X. So if this is proportional to F, then F is proportional to this. You follow? Okay, now, so we have got F is proportional to mv minus mu by t. So therefore F is proportional to, now here we can take m common. If you take m common, what will be the other part? V minus u by t, isn't it? You take m common, so v minus u by t. Now v minus u by t is what? Acceleration of the body. So what is the acceleration formula? V minus u by t, isn't it? So now we can write, so I am writing here. So we get what? F directly proportional to m into a. So this acceleration. So v minus u by t is replaced by a, because that is the formula for acceleration. All right. So F proportional to ma. F proportional to ma. So thus we get F equal to kma. Now again we are using another law of variation, another law of proportionality. So that law says if X is proportional to Y, then X equal to k into Y. So this is another law of variation or proportionality. If X is proportional to Y, then X must be equal to k into Y. What is k? K is a constant. It is a number. So where k is a constant. So using this law of variation, we get this one. So this is replaced by equal sign. So we bring kma. We bring k. What is k? K is the constant of proportionality. So that you must be written, that you must write when you do in exam. So where k is constant. K is constant of proportionality. All right. So k is constant of proportionality. So this becomes equal, and k comes here, k into m into a. What is k? K is constant of proportionality. Okay. So we get F equal to kma. But as I told you in the beginning, we have to get this formula, F equal to ma. We got F equal to kma, but we have to get this formula. This is the formula for second law, F equal to ma, mass into acceleration. Now how to remove this k? We can remove k if we make k equal to 1. Suppose k value is 1, then F will be equal to what? 1 into ma, that means ma. Now, in order to make this k value 1, scientists have brought a definition of unit force, So, to make this value, make this constant equal to 1, physicists have brought a quantity called unit force. Unit force means a force whose value is 1. A force whose value is 1 Newton. All right. Now, scientists have defined unit force as that force which produces unit acceleration of a body of mass of unit mass. So you say unit. So to make this value of K1, scientists have brought a quantity called unit force, and they have defined unit force as that force. Unit force is that force which produces unit acceleration. That means acceleration 1, unit acceleration of a body of unit mass by acting on that body. So in order to make the value of K1, scientists have defined unit force as that force which produces unit acceleration of a body of unit mass by acting on that body. So that means unit force F is 1, unit acceleration A is 1, unit mass A is 1. So that is, therefore, what we get? F equal to 1, unit force F equal to 1, unit acceleration A equal to 1, and unit mass M equal to 1. So these three quantities are 1 now. F equal to 1 unit, A equal to 1 unit acceleration, M equal to 1 unit mass. Now you see. Now this definition of unit force, when you must write in exam. Many students don't write. After this, simply they write K equal to 1. But why K equal to 1? If you don't write, then you will never get full marks. So in order to make K1, what is done? We have brought a quantity called unit force, which is defined as that force which produces unit acceleration of a body of unit mass by acting on that body. So F is 1, A is 1, M is 1. So therefore, this formula F equal to KMA. Therefore, F equal to KMA. This becomes what? It becomes, this formula now becomes F is 1, K into M. M is 1, A is 1. So you just put the value F1, A1, M1. So F1, M1, A1. So this gives what? This gives K equal to 1. So you see how we have made K equal to 1. Now put the value K1 here. So therefore, yeah, so let me write here. Therefore, we get F equal to, now putting the value of K1, 1 into MA. That means 1 into MA, that is F equal to MA. So this is the formula for Newton's second law. That means force equal to the product of mass and acceleration. So after making K equal to 1, so we put the value of K here. Therefore, F equal to 1 into MA. That means F equal to MA. So we have derived the formula for our mathematical expression. Mathematical expression for Newton's second law. So in words, it will be force equal to product of mass and acceleration. So F equal to MA. Okay. So this is the derivation. I hope you have got it. Now let us see one derivation from this formula. Okay. Okay, now see F equal to ma. That means F equal to m into a. Now what is a? V minus u by t. All right. So by cross multiplying, what you get? F into t equal to mv minus mu. So mv minus mu by t. So cross multiply this. All right. Now you see this is the formula for change in momentum. So mv minus mu, this is change in momentum. Now change in momentum equal to F into t. That is force into time. Okay. Now coming to this SI unit. Now you see momentum SI unit what? Momentum is mass into velocity. So what is the SI unit of momentum? SI unit of mass is kg. SI unit of velocity is meter per second, isn't it? Therefore, what will be SI unit of momentum? Kg meter per second. This is the SI unit of momentum. Mass is kg, velocity is meter per second, ms to the power minus 1. So kg meter s minus 1. This is the SI unit of momentum. All right. Now this is the here. This is momentum. So what is it? SI unit? This one, kg meter per second. But that is equal to also ft. Now what is ft? F is Newton. F is Newton. So SI unit of force is Newton. Newton into time. Time is second. So Newton second. So this is another unit of momentum. You see, this is also momentum. So momentum has two SI units. So the main momentum, main SI unit of momentum is this one. Mass into velocity, that is kg meter per second. But we see this change in momentum. Change in momentum is this one only, kg meter per second. Now this is equal to ft. Now F is Newton, T is second. So this is another SI unit of momentum. So Newton second. This is Newton second, ns. This is ns. So ns or this one, that is SI unit of what? Momentum. Okay. All right. Now this quantity ft, this quantity is called impulse. So how will you define impulse? Impulse is a product of force and time. I mean, numerically it is equal to change in momentum. But what is the definition of this ft? Ft, this term is called impulse. And impulse is defined as a product of force into time. Product of force and the time during which the force is acting. All right. If force is suppose 2 Newton and t is suppose 5 seconds. If force is 2 Newton, t is 5 seconds, then what will be the impulse? 2 into 5, 10 Newton second. So 10 Newton second will be impulse. So this quantity is called impulse. And what is its unit? Newton second. In other words, it is similar to what? Momentum. Okay. Okay, now let us see. Now in this F equal to ma, one important thing you have to remember. So F equal to mass into acceleration. Now this mass is the mass of the body on which the force is acting. Now suppose there are two bodies, say it is body A and body B. Now body A mass suppose 6 kg and body B mass suppose 5 kg. So consider two bodies A and B, A mass 6 kg, B mass 5 kg, and A is applying a force on B. A is applying a force on B. Suppose A is pushing B. Suppose A is a person, B is a box lying on the floor. So the man is pushing the box constantly. Okay. Now A is applying a force constantly on B, and mass of A is 6 kg and mass of B is 5 kg. Because of this force, B has acquired an acceleration, suppose 2 meter per second square. Acceleration is 2 meter per second square. Now the question is, Yes, what is the force? Calculate the force. Calculate the force. Now, force equal to mass into acceleration. Now, do not be confused which mass you will take. So, you will take this mass, mass of B, because on B the force is acting. So, in this formula, remember this m is not this m is not the mass which is applying force, but it is the mass of the body on which the force is applied. So, here F equal to what? Mass into acceleration. So, 5 into 2, mass into acceleration. Why 5? Because the force is acting on B. So, this is another confusion suffered by students. So, they are confused now which mass they will take. Two masses are given. Now, this mass is given just to confuse the student. So, remember you have to take this mass because this is the mass on which force is acting. Okay. These are minor things, but then also very minor. Sometimes minor things are very important. Students make mistake. Okay. All right. Now let us see a question. Let us see a question. Yes. Now suppose this, consider a car. So let us consider a car whose mass is 1 ton. 1 ton. Now 1 ton means how many kgs? 1000 kg. All right. Suppose a car of mass 1 ton. All right. Now it is moving with initial velocity. Initial velocity suppose 20 meter per second. 20 meter per second. So consider a car whose mass is 1 ton. That means 1000 kg. It is moving with an initial velocity, uniform velocity of 20 meter per second. Then a force is applied on it. Now the force is applied on it by the accelerator. If you want to increase the speed of a car, what do? You press on the accelerator constantly, and that accelerator applies force on the car so that it acquires its velocity gradually increases. So that accelerator is using a force which you have to find out constantly on the car, and the final velocity becomes 30 meter per second. So the car was moving with 20 meter per second uniform velocity. Then the driver has pressed on the accelerator. So the velocity will gradually increase. So after some time, the velocity has become 30 meter per second. 30 meter per second in what time? In 5 seconds. In 5 seconds. The driver has pressed on the accelerator, applied the accelerator for just 5 seconds. In 5 seconds, the velocity has increased from 20 to 30. Now the question is, what is the force applied on the car? What is the force applied on the car by the accelerator? So a car, this mass that is moving with this uniform velocity, then the driver applies the accelerator for 5 seconds constantly, and the velocity increases to 30. Now you are required to find the force. So very simple. So using the formula F equal to ma, what we get? Force applied on the car is mass of the car. Why mass of the car? Because it is on the car on which force is applied. So 1000 kg, 1000 kg into 1000 kg into acceleration. Now acceleration, okay, well, let us first find out the acceleration. First, let us find out the acceleration, otherwise the calculation will be long. All right. So from here, let us find out the acceleration using the formula v minus u by t. So acceleration of the car. So time is 5 seconds, and v is 30, and u is 20. All right. Therefore, what is 30 minus 20? 10. 10 by 5, 2. So 2 meter per second square. This is the acceleration of the car. Now we can find the force. So force applied on the car by the accelerator is equal to what? F equal to ma. M into A. Now M is what? M is 1000 kg. So 1000 kg into A. A we have found out 2 meter per second square. 2 meter per second square. So what do you get? 2000 kg meter per second square. So see the unit, it's a long unit, 2000 kg meter per second square. So kg meter per second square is the SI unit of force. Kg meter per second square is the SI unit of force, but since it is long, scientists have devised a simple word Newton. So this whole thing is replaced by one word Newton. So after to honor the great scientist Sir Isaac Newton, so this kg meter per second, this long SI unit is shortened to just one word Newton, and symbol is capital N. Symbol is capital N. Therefore, how will you write the answer in exam? 2000 Newton. So this is how you will write the answer. So 2000 kg meter per second square. So you will write kg meter per second square replaced by Newton, that is N. So this is the answer. This is how we have to use the formula F equal to ma. Is it clear? Okay, now let us see another example in which the brakes are used. Now here the driver is using on the car accelerator. The accelerator is applying the force. Now let us see the car is moving, brakes are applied. So this is another example. Suppose that car whose mass is 1000 kg. 1000 kg. Now suppose it is moving with initial velocity 50 meter per second and the brakes are applied. The car is moving with uniform velocity 50 meter per second and driver has pressed on the brake constantly, all right. Then the car will slow down and finally the car stops. Velocity is 0. Final velocity 0, and these brakes are applied for what time? 10 seconds. So a car is moving, this is the mass of the car, it is moving with uniform velocity 50, then the driver has applied brakes. As a result, the car slows down. The driver has applied brakes constantly for 10 seconds. So in second, the car has come to a rest. So V equal to 0. Now the question is, find the force that brakes applying on the car. What is the force applied by the brakes in the car? Okay. So first of all, let us find out A. A equal to V minus U by T. That means A equal to V. V is 0, 0 minus 50. 0 minus 50 by 10. So that means what you get? Minus 5 meter per second square. So this is the value of A. Now this minus, it is negative acceleration. So when the brakes are applied, the car slows down. That means the car acquires negative acceleration. But when accelerator is applied, the car, speeds up. That means the car acquires positive acceleration. So this is a case of positive acceleration. Now this one is example of negative acceleration. This is why this minus is coming. Okay. Now the question of applying the force F equal to ma. So we are asked to find the force applied by the brakes in the car. So F equal to what? Ma. F equal to ma. So what is m? 1000 kg. 1000 kg into minus 5. A is minus 5. All right. That means minus 5000. Minus 5000 kg meter per second square or Newton. So this is the answer. All right. Now when you do the sum, you need not write the unit. These units I wrote just to show you, but in the exam don't write the unit. Write the unit only in the final answer. Do not write the unit when you are calculating in between. Write the unit only in the final step. So F equal to what? Minus 5000 unit. Now why this minus implies retarding force. So write that within bracket, retarding force. The brakes apply retarding force. So when you get minus, you indicate within bracket retarding force. But when you get plus, don't write anything. Okay, for minus, just write retarding force. Is it clear? Okay, now, yes, so another numerical example using that Ft equal to mv minus ma. All right. Yes, now this question. Find the change in momentum. Find the change in momentum. Find the change in momentum of a body. Find the change in momentum of a body whose mass is 10 kg. It is moving with uniform initial velocity 2 meter per second and final velocity 5 meter per second. So this information is given in the question. So a body of mass 10 kg is moving with uniform velocity 2 meter per second, and due to application of a force, its velocity increases to 5 meter per second. That means it acquires acceleration. When v is greater than u, that means positive acceleration. When v is less than u, it is a case of negative acceleration. Okay. Now you have to find out what change in momentum. Now change in momentum is a formula mv minus mu. mv minus mu. This is a formula for change in momentum. Change in momentum equal to mv minus mu. Why mv minus mu? mv is the final momentum, mu is the initial momentum. So final momentum minus initial momentum, that will be change in momentum, isn't it? So mv minus mu. So mv is what? M into v, 10 into 5, 50. 50 minus mu. So 10 into 2, 20. So change in momentum is final momentum minus initial momentum. Final momentum is m into v, 10 into 5, 50. Initial momentum m into u, 20. That means 30. 30, and what is the unit of momentum? Kg meter per second. So this is answer, 30 kg meter per second. So mass of a body is 10 kg, initial velocity 2, final velocity 5, all is given in the question. Find the value of change in momentum. So use the formula mv minus mu, so you get this one. Okay. Now for change in momentum, yes, we can use also ft. We can use the formula ft, because you see that already I gave you that relation ft equal to mv minus mu. Ft equal to mv minus mu, isn't it? So ft equal to mv minus mu. Now if mass u v given, if mass is given, u given, v given, then you will use this formula. Change in momentum is mv minus mu. But sometimes this will not be given. What will be given? Only force and time given. For example, this question, you see, all these are exam questions. A force of 10 Newton is applied on a body for 2 seconds. So you see, just the question, a force of 10 Newton is applied on a body for 2 seconds. See, only this is known, nothing else is known. See the question, a force of 10 Newton is applied on a body. Body of what mass and all, we are not told. Simply a force of 10 Newton is acting on a body for what time? 2 seconds. A fine change in momentum. So we will use this form ft, because ft equal to mv minus mu, change in momentum. So now here we cannot use mv minus mu because m is not known, v is not known, u is not known, therefore we cannot use this formula. Now we have to use this form ft. So change in momentum equal to what? ft, f into t. F into t, that is equal to 10 Newton into 2. So equal to 20. Now this time what will be a unit? Newton, ns, Newton second. So what is the change in momentum? 20 Newton second. So Newton second and kg meter per second, both are units of what? Momentum. But this one you will use only when it is a case of change in momentum or impulse. As I told you before, this is called impulse. Suppose you are asked, find the impulse, then ft. Find the change in momentum, then ft. So this f into t is also called impulse. Okay, so I hope you have been benefited by this discussion. All right. So today we'll stop here, but then we'll continue with more numerical example involving is second law of motion, and the formula F equal to ma, and the formula Ft equal to mv minus mu. All right. Now, before I wind up, again, let me tell you, subscribe. So, if you think you have been benefited by this discussion and tutorial, so subscribe to my channel. All right. My WhatsApp number 8486768385 if you want to communicate with me. 8486768385. If you want to communicate me, send any. If you want to send any queries, question, which you want me to explain. All right. Okay then. So that is all for today. Thank you.